So this is the reaction between benzaldehyde and ethylene glycol in acidic solution. The first thing that happens is the lone pairs of electrons on the benzaldehyde's oxygen will attack the proton, and then that produces this product. So because oxygen here only has 5 electrons contributing to it, it has a positive charge. However, it's still very highly electronegative, so the carbon that's attached to it will develop a partially positive charge. Because it's partially positive, the lone pairs of electrons on the oxygen of the ethylene glycol will attack it. Then that creates a shift in electrons, and the electrons from the double bond will move up towards the positive oxygen. This produces another product. So what happened here was that the electrons from the double bond are shown as a lone pair, and the attached oxygen from the ethylene glycol now has a positive charge. The lone pair on the oxygen takes part in internal proton transfer, and it grabs the hydrogen from this oxygen. Then that means that the electrons in that bond collapse onto the oxygen. So now this oxygen has 2 hydrogens, one from the proton it first got, and then another one from the ethylene glycol. Now, water is a good leaving group, but for that to happen, first, these electrons form a bond here, a pi bond with this carbon, and then that removes a bond in order for carbon to have 4 bonds. So the electrons are then given to the oxygen. Here we can see the pi bond formed, and that leading to the oxygen having a positive charge, and then the water was set aside in a different color for clarity. So what happens next is the lone pair from this alcohol will attack the partially positive carbon, and then that leads to the pi bond breaking, and the electrons will be moved to the positive oxygen. Because the pi bond was removed, the oxygen here now has 2 lone pairs, and this oxygen that attacked the carbon now has a formal positive 1 charge. So because the solution was acidic, for example, like hydrochloric acid, the conjugate base pair would be chlorine, and the electrons from this would attack the hydrogen. That would lead to the electrons from the bond to move back towards oxygen. And then the final product is given here. So thank you. Oh, and here's the hydrochloric acid reformed. Thank you.